Assalamu alaikum wa rahmatullahi wa barakatuh. A month ago, I was having a new experiment opportunity, which is after God the reason of making my vision and goals to myself limitless. During this opportunity, I learned that some steps need to be taken alone. To the only way to figure out where I need to go and who I need to be. I am Sami Muhammad Alhawsaw, and I will discuss with you my summer training at King Abdulaziz University, based in the utility department, organized and sponsored by the KAU Vice Presidency for the project. Organization trainer is Engineer Abdul Hafiz Al Ahmadi, and my instructor is Dr. Saeed bin Ahmed Asiri. The topics that will be covered during this presentation are shown in this slide, starting with the introduction, then ending with the discussion and recommendation. A best short road, which is the start of a long journey that is full of passion, joy, challenges, obstacles, opportunities, and more. All the mentioned circumstances are dedicated to enhancing our skill, ability, and knowledge. Thus, summer training is a golden opportunity that is the start point of the journey, which provides me with a hands-on experience for applying my knowledge on the live projects in order to develop professional skills. As I pointed out previously, the start point for me is the summer training, and it was at King Abdulaziz University based in the utility department. My goal throughout this training opportunity is to see, ask, do whatever it takes to make me a better student as well as engineer in an ethical way. Moreover, personality development as well is targeted while working within teams to reach a high professional expectation. Again, it's just the start. To obtain a best learning experiment which can be measured later, me and the organization made list of expected training learning outcomes. First, you can see my expected learning outcome, which are working in a team to accomplish work at specific time, teamwork skill, idea resilient, and enthusiasm. While the organization expected training learning outcomes are also presented in this slide, like the attendance of distribution pump, shield pump, and condenser pump maintenance, locally follow the cycle of plants, following air conditioning of building, follow workshop job, following operational process of the planet, attendance of fluid cooler fan preventive maintenance. When it comes to the organization, this space is actually not enough to fulfill its right. However, I will try to present some important information about the university. King Abdulaziz University (KAU) was established in 1967 in the city of Jeddah by the Red Sea as a private university bearing the name of the founder of Saudi Arabia, King Abdulaziz Al Saud, in order to serve the need of higher education in the western region of Saudi Arabia. In 1974, King Abdulaziz University joined the Saudi public university system. Since then, King Abdulaziz has gained successful experience and pioneered many academic systems and traditions in the development of higher education in the kingdom. However, and it is one of the top public university in Jeddah, located in Saudi Arabia, of course. It is ranked 143 in QS Global World and hashtag number 1 in Arabic region according to the QS 2021. Safety in the organization. To be specific at the utility department. Why workplace safety is important? There is more to this question than one thing. Workplace safety is very important for each and every employee in the industry because all the workers desire to work in a safe and protected atmosphere. Health and safety is the key factor for all the industries in order to promote the wellness of both employees and employers. It is a duty and moral responsibility of the company to look after the employees' protection. There were some safety tools we were commanded to buy from the market, including air block, safety helmet, safety shoes and goggles, and also safety vest. In addition to that, the plant were strict about the social distancing and wearing respirator due to the crisis of coronavirus COVID-19. Therefore, we were divided into groups, each group composed of 3 persons. However, the organization was able to provide us with those tools, but due to the crisis, each person is responsible for his personal need. The training was for 2 months, which include 8 weeks. Thus, on each week there is a specified area that we must follow, starting from the first week of the KA workshop and starting date of the training is from 24/6 and it ends in week 8 in the sport village at 28. Also, you can see the name of the plant supervisor presented in this slide. First week was at KAO workshop. KAO workshop is a great place where over several workshops like blacksmith shop, carpentry workshop, plumbing and electric workshop. The main purpose of those workshops is to offer and fabricate some of the essential consumed equipment that need later for the maintenance and replacement. Main university gate, tire killer, barrier gate, and more of those equipment are considered to be the KAO blacksmith shop responsibility. Lathe machine, drill, arc welding, electric saw, hammer, all those tools are contributed to manufacturing those equipment. First, I will discuss with you a hinge. Our gate joint is a mechanical bearing connect two solid objects typically allowing only a limited angle of rotation between them. Two objects connected by an ideal hinge rotate relative to each other about a fixed axis of rotation. To fabricate a hinge must have a drawing sheet that contains all necessary dimension tolerance and material. Then lathe machine and drilling are used to make half of a hinge. The type of material typically include aluminum and steel. The second equipment that I want to discuss with you is the tire killer. Tire killer is especially designed for the entrance point which have the threat of vehicle attack or for the one that have high security requirements. The need of manufacturing those tire killer in KAO workshop is due to a high price of purchase them from the market. The price in the market is about 1,700 Saudi Arabic Riyal. A tire killer usually involves of steel plate, steel sheet, steel rod, steel frame or chassis, and steel fixture. Steel fixtures are being fixed to the end of each plate to fix and allow a vertical movement of the plate up and down. The third equipment that I want to discuss with you is the barrier gate. Our boom barrier is a bar or bull pivoted to allow the boom to block vehicular or pedestrian access through controlled point. Typically, the tip of a boom gate rises in a vertical arc to a near vertical position. Boom gates are often counterweighted, so the bowl is easily tipped. Boom gates are often built either end to end or offset appropriately to block traffic in both directions, and this kind of barrier would adapt, blocking traffic in both directions. In the fifth week of my training, we went to the current university. Its name refers to the old university building, and that's including 27 buildings. During this week of training, we were concerned about the maintenance sector that's responsible for the current university, duties and tasks that should be performed to keep the legacy and heart of KAU running and performing well. There are 25 technicians and 5 supervisors work there. The technical meaning of maintenance involves functional checks serving disambiguation, need repairing or replacement of necessary device, equipment, machinery, building, infrastructure, and supporting utilities in industrial, business, governmental, and residential installation. Maintenance has many types. However, KAU preventive and reactive maintenance were considered in KAU current university. First, let's talk about the reactive maintenance, also known as breakdown maintenance or corrective maintenance, referred to repairs that are done when equipment has already broken down in order to restore the equipment to its normal operation condition. Ideally, this method should only perform on parts that are inexpensive and easy to replace, like the light bulb, door lock, etc. It is also requiring less staff, less planning, and a lower initial investment, so it is a go-to in a lot of facilities. The second type, which is the preventive maintenance, it is a routine for periodically inspection with the goal of noticing small problems and fixing them before major ones are developed. Ideally, nothing breakdown, like the periodic check tour that we had have to several buildings. During the tour, we were checking the air conditioning, toilet, if there any water leak. Also, we checked outside the building, like water sprinkler in the outside garden. Some of the necessary equipment that needed to be changed periodically including handheld bidet, especially at summertime due to the high sun temperature that caused the handheld bidet to melt, thus it is needed to be changed. Charcoal air filter of the air conditioning are also needed to be changed every 3 months. Charcoal air filter is used in air conditioning unit and exhaust fan to rid air of unwanted odor, smoke, fumes, and animal odor. IBM Maximo software is used by the maintenance team, which is enterprise asset management software designed to assist an organization in managing its assets. The next day, we went to the basement of Building 121, Faculty of Economics and Administration. Water chiller is typically used, which cool the air in their respective space. The advantages and disadvantages of using chilled water are presented in the following table. First, let's talk about the advantages. Longer lifespan. They are not exposed to outdoor elements such as rain, snow, ice, and heat, which make them less vulnerable. Quiet operation. No open space needed. Water-cooled chillers stay inside buildings, which make them ideal for companies that don't have access to enough outdoor space. It's also safe. Water-cooled chillers use water as a refrigerant instead of Texas chemical. This makes them safe for people who have contact with them. While the disadvantages are high cost, more maintenance, require mechanical room, which I will cover later, and complicated insulation. I want to refer that the refrigerant used in the cooling process is R22. Also, the plant contains an air handling unit. Also, it will cover later. In the third and fourth week, we're at Central Cooling Plant 1 and 2. In the current university, we saw the air handling unit, AHU, which is an essential element of the air conditioning operation. However, Central Cooling Plant 1 and 2 are stations where a lot of operations that precede the process of the AHU are conducted and establish the base of the air conditioning system. And the aim of those stations is to produce chilled water. I will cover those topics during the few slides, starting with the mechanical room, then followed by plant general information, the plant system description, heat, ventilation, and air conditioning system equipment, water chiller system, cycle process, and plant summarizing. Those plants need mechanical room, which is a room or space in the university dedicated to the heavy mechanical equipment and its associated electrical equipment, as opposed to room intended for human occupancy or storage. It is often requiring multiple rooms throughout the building or even occupying one or more complete floor. Mechanical room typically housing the following equipment: air handling unit, boiler, chiller, heat exchanger, water heat and tanks, water pumps, main distribution piping and valve, sprinkler distribution piping, backup electrical generator, transportation equipment, and other heat, ventilation, and air conditioning system. The next topic, which is general information about the plant. The plant consists of 19 New York water chiller with a cooling capacity of 2,185 tons per hour for each cooler. So the total is 60,000 tons per hour. 14 of them are CYK chiller and the other 5 are OM chiller. There are total of 120 radiator fan or fluid cooler to cool the condenser cycle. It had the largest ice tank in the world, with a total of 6 tanks that produce ice of total of 126,720 ton refrigerant. R134A is used as main refrigerant. There are 8 distribution pumps with the capacity of 84,000 gallons per minute. 15 of energy transform stations are installed and distributed around the university building to save energy. When it comes to the plant system description, the plant work open automated controlling system through the central controlling room inside the plant, where the operational state of the plant equipment and university buildings is monitored through monitors. From 7 a.m. to 8 a.m., the plant produces cold water at a temperature of 35 Fahrenheit through pumps to feed the assigned building. Throughout this period, the cold water from the cooler chiller, in addition to the melt iced water, are being used. The temperature of the returned water to the plant is designed to be 59 Fahrenheit. Mechanical cooling devices are used at a minimum to conserve energy while increasing operational efficiency. While from 8 p.m. to 7 a.m., feeding is done by CYK Tab York chiller, and the temperature of the feed water is from 40 to 42 Fahrenheit. Meanwhile, OM Tab York chiller are being used to form the ice via glycol. As I mentioned previously, the method used to cool the air in the central planet 1 and 2 is chiller water system. In the next slide, I will discuss with you the kind of the chiller and its component, also the other equipment used as part of the heat ventilation and air conditioning system, such as AHU, ATS, and their mechanism. That the fundamental element in heat ventilation and air conditioning system, including chiller, air handling unit, heat exchanger, energy transfer station. First, let's talk about a chiller. A chiller is a machine that removes heat from a liquid via vapor compression, adsorption, refrigeration, or absorption refrigeration cycle. This liquid can then be circulated through a heat exchanger to cool equipment. Our another process is steam, such as air or process water. In the central cooling planet 2, there are two types of York chiller: CYK chiller and OM chiller. The cooling capacity is 60,000 tons per hour. 14 of them are CYK chiller and the other 5 are OM chiller. In the planet, there are 14 of CYK chiller. This type of chiller has the capacity of 2,185 tons per hour for each one. Usually come in small size compared to an M-can. Those type of chiller are centrifugal one. It is characterized by using two centrifugal compressor for high heat condition and differential process. Also, it consists of a flash economizer. Also on board controlling panel simplifies operation. York CYK compound centrifugal liquid unit are factory packed, including the evaporator, condenser, compressor, motor pump, lubrication system, control center, and interconnecting unit, piping, and wiring. The function of each equipment are as follows. The evaporator or cooler reduce chilled water. Condenser remove the waste heat from the cooling load and compression work for dissipation by cooling water outdoor. Economizer separate the liquid water from the gas, and the compressor which raises the refrigerant pressure and temperature. Drive motor provide compression power. Expansion valve restrict the flow of refrigerant. When it comes to the OM chiller, components of this chiller are the same as the CYK chiller and they do the same function. However, the difference is that OM chiller has two evaporators. The first evaporator produces chilled water, while the other is one responsible of producing ice. The first evaporator is producing ice or producing chilled water with the capacity of 3,600 tons per hour for each. The other evaporator is to form ice in tanks with the capacity of 2,185 tons per hour for each. When it comes to the ice tank, they are the largest ice tank in the world with the storage capacity of 126,720 tons. Glycol, which is a chemical compound, is added to water that enters those ice tanks through pipe. Thus, it allows smoothly movement of the water at 0 Celsius degree, so the water does not freeze. Inside the ice tank, 75% water and 25% glycol. Also, there is an air blower to melt the ice inside the tanks and used during daylight while the ice formed at night time to save the energy. The third element that I want to discuss with you is the air handling unit, or AHU. Air handling unit is a device used to regulate and circulate air as part of heating, ventilation, and air conditioning system. It's used to control the temperature, humidity, air movement, air cleanliness. It consists of a mixing box. This box has air inlet that is attached to the damper. This is the place where the outside air and the return air are mixed to provide the correct proportion of air to be distributed to the space that is to be conditioned. The second element is a filter. Filters are to remove particles and contaminants of various sizes from the air. The third element is the cooling coil or radiator. Cooling coil is used to cool and dehumidify the air. These coils are arranged in row with the different fin spacing. Aluminum fins and copper tube are used in the design of the coil. The corrosion resistance hydrophilic fins are also used due to its lower cost and lower resistance to the air velocity. The supply fan section. Centrifugal fan is used to circulate the air to the various parts of the section in the building by using motor. Now let's talk about the heat exchanger, which including 120 radiator fan located outside the plant. Due to the large space they need, the main purpose of using those fans is to cool the condenser cycle. Some of the maintenance work including belt bearing, retain blade angle, radiator cleaning, and also bearing greasing. The energy transform station. The purpose of using this station is to make sure that the chilled water is delivered to the building with the specified temperature as well as leaving to the plant. To control the temperature, pneumatic valve is used, and the controlling process is done by controlling the amount of the flow of the hot water that leaving from an AHU and entering the AHU again. This valve has three operational options: fixed, auto, and variable. Variable consists of fixed and auto. In the university, there are 15 of ATS distributed around the university. The aim of the plant is to produce cold water. To do so, it must undergo three main cycles, and they are as follows: condenser cycle, refrigerant cycle, and chill cycle. The first cycle that is responsible for cooling the refrigerant as a first step using fan is the condenser cycle. The return hot condensed water that is going to the fan is first flowed through a total of 19 pipes, then gathered in one pipe. Moreover, it goes to the fan through 5 pipes. Later, after the water is cooled, it goes back to the condenser cycle to exchange heat with the refrigerant. The refrigerant used in this plant, as I mentioned previously, is R134A. Water temperature before fan is 120 Fahrenheit and after is 115 Fahrenheit. Chiller remove heat from water by means of a refrigerant cycle, which is the second cycle. I am going to discuss it with you. It consists of condenser, expansion valve, evaporator, and compressor. A chilled water system refrigeration cycle works by removing heat from chilled water in the evaporator of the chiller. The compressor is what drives the entire process. It also uses the most energy in a chilled water system. In the condenser of the chiller, the heat is transferred to the condenser water. The liquid refrigerant goes through the expansion valve, also called throttle valve, where its pressure abruptly decreases. This results in a mixture of liquid and vapor at a low temperature and pressure. The cold liquid vapor mixture then travels through the evaporator coil and it's completely vaporized by cooling the warm air from the space being refrigerated, being blown by a fan across the evaporator coil or tube. The resulting refrigerant vapor returns to the compressor inlet to complete the thermodynamic cycle. The chilled water loop which is the last cycle, consists of pipe and distribution pump that move chilled water around the building. A chilled water pump pushes chilled water through the chiller and through the chilled water line around the building, and the water returns into the evaporator with 11.3 Celsius degree temperature. The chilled water that exits chiller is called the chilled water supply. The chilled water supply temperature is usually above 45 Fahrenheit. The chilled water supply is pumped through the chiller and to the building various air conditioning units such as air handling unit and fan coil unit. Finally, I can summarize the goal of this process or this planet, which is producing cold water with a temperature of above 45 Fahrenheit. Later, it goes to the ATS to adjust and controlling the water temperature. Also, it saves energy. Finally, the AHU will transfer this chilled water into fresh air that can be used to control the comfort of the university's building. Next topic that will be covered with you is the academic field. Maintenance and taking care of the academic field building is a responsibility of Administration of Maintenance and Operation Department. It is a separate department located at the basement of the engineering facility. Three strategies are adopted, including a corrective, preventive, and emergency maintenance. Maintenance work, including restoration and painting, operation, lighting service, air conditioning, plumbing, door and suspended ceiling. Also electric services such as outlet plugs and a lot of operation which guarantee a stable sustainability of those buildings. I will present you some of the problems that we solved during the summer training with the technician. The problem states that the air conditioning in building 91 fourth floor is somehow hot, so it is comfort problem. We solve this problem by following those three steps. First, we want to AHU4, which is the responsible AHU for the air conditioning problem on the fourth floor. So we want there. Before that, we check the water temperature to make sure that the problem inside the AHU itself, not from the distribution station. We check the water temperature and it was good. So the problem inside the AHU4. After we have knew that the problem inside the AHU, we check the air filter. And we found out that the problem from the filter, so that it was filled with dust. We solved this problem by cleaning the filter with the water. In the sixth week of my training, we went to the boiler plant. The boiler is a closed vessel in which water is heated. When the water is heated, it exits from the boiler for use the various process. Our heating applications such as water heating, central heating, cooking, and sensation. For the boiler in King Abdulaziz University, the heated water is mainly going to the hospital for the use of medical tool. The boiler in King Abdulaziz University were working over 30 years. There are three types of boiler. However, in KAU they use the fire tube boiler. This type of boiler, in which hot gas goes through one or many tubes running through a settled vessel of water. The heat of the gas is transferred through the wall of the tube by thermal conduction to heat the water. In the 7th week in my training, I went to the swag treatment plant. One of the main and essential processes that dealing with the water swag in King Abdulaziz University is the water swag treatment plant. This plant is responsible for treating the water swag all over the university facility. The process is defined as removing contaminant from swag or wastewater and convert it into effluent that can be reused for various purposes with acceptable impact on the environment and less contaminants. Treating wastewater has the aim to produce an effluent that will do as little harm as possible when discharged to the surrounding environment, thereby preventing pollution compared to releasing untreated wastewater into the environment. Swag treatment generally involves three stages called primary, secondary, and tertiary treatment. Let's first talk about the first stage, which is screening. Before the swag water goes to the primary treatment, firstly the filtration of swag typically include a process created to filter solid and large objects like diapers, nappy, sanitary item, cotton bud, face wipes, and even broken bottle top plastic and rug that may block or damage equipment, which are then collected in dumpers and disposed of in landfill. Fat and grease are also removed before the primary treatment of swag. Swag water can travel toward treatment plant via piping and in a flow aided by gravity and pumps. However, in KAU, there are four pipes that's responsible for transferring wastewater to the next step. Typically, four pumps are also used. The second stage is the primary treatment or clarifying tank. This involves the separation of organic solid matter, our human waste, from the wastewater. This is done by putting the wastewater into large settlement tank for the solid to sink to the bottom of the tank. The settled solid are called sludge. At the bottom of the circular tank, large scrubber continuously scrub the floor of the tank and push the sludge toward the center where it is pumped away for further treatment. The rest of the water is then moved to the secondary treatment. Clarifier tank have diameter of 20 meter and depth of 3.5 meter. The third stage is the secondary treatment or rotation tank. The water at this stage is put into large tank. These are called rotation lanes. Air is pumped into the water to encourage bacteria to break down the tiny bits of sludge that escape the sludge scraping process. The fourth stage, also the filtration. The almost treated wastewater is passed through a settlement tank. Here more sludge is formed at the bottom of the tank for the settling of the bacteria action. Again, the sludge is scrubbed and collected for treatment. The water at this stage is almost free from harmful substance and chemical. Then the effluent is kept into a huge storage tank. Later, the effluent flows through distribution station that release and distribute the effluent to all over the garden of the university with the flow rate of 2,500 cubic meter for each line of total of 3 lines. In the final week of my training, I went to the sport village. The sport village is the place where there are many sport facilities such as swimming pool, football, basketball, and bowling. The engineers in the sport village are responsible for the maintenance process such as the extensive heating, air conditioning, refrigeration, and ventilation system, including air handling unit. Also, there is a regular maintenance of swimming pool water to clean it from impurity and dirty, so that there is a filter and pump system to clear away this dirt and remove all bacteria from the swimming pool water. A combined network of piping, suction pumps, and filter continuously work to circulate the water. The dirty water in the swimming pool is sucked out by skimmer existing on the top wall of the pool. Then the dirty water goes by pipe to be filtered and returned to the swimming pool again after it is being cleaned. At the end of this training, I was lucky to be a part of the King Abdulaziz University based in the utility department. My training there were for 2 months. Those 2 months were valuable to me. A lot of knowledge were gained as well as personal skill based in communication, teamwork, English writing, speaking were developed. Some major skills such as critical thinking, time management, problem solving, flexibility, and other were also stepped up. At the very first day of the training, safety instructions of the plant were introduced to us. They gave us a lecture of about 1 hour explaining some important safety tools that contribute to our healthiness so we can get back home safely. The rest of the week they were off. In the next week, we went to the first scheduled plant, which is the KAU workshop. We saw the manufacturing process of some spare equipment, including the university gate joint, tires killer, and barrier gate. Through this week, we fabricate a gate joint using a lathe machine. In the second week, we moved to the current university where maintenance work and method were taught. The third week of training, we moved to the central cooling unit 1. We attend the fluid cooler fan preventive maintenance. We saw the chiller system and its operation process. In the next week, the fourth one, we went to the central cooling unit 2. This plant is equipped with modern chiller and it has the ability to produce chilled water and pump it to AHU via the distribution pump. In week 5, we moved to the academic field that's responsible for a general maintenance of the academic field building. The boiler plant was the next station. This plant produces hot water that feeds the hospital for medical tool usages. In the 7th week, we went to the water swag treatment plant. The plant produces effluent that will do as little harm as possible when discharged to the surrounding environment. In the final week of my training, week 8, we went to the sport village and we saw the swimming pool filter and how maintenance work done. Finally, I want to refer that most of the topics we learned throughout this training are related to the thermodynamics and heat transfer application, which added more knowledge to what I have.